I'm Susie Maidenment, and I have a degree in paleontology from Cambridge University, and my PhD was in the systematics and phylogeny of Stegosauria, which is the relationships between all the different types of stegosaurs.
And you're the only person studying stegosaurs, huh?
Pretty much. There's not too many people in the world who are studying stegosaurs at the moment.
Why is that?
Well, I don't know really. I mean, I suppose the Morrison Formation is not. There's not a lot of people working in the Morrison Formation at the moment. Not a lot of people digging in America in this. You know, there's much more research going on into the Cretaceous formations and into the Clovelly Formation and the Hell Creek and the Judith and things like that. So there's not a lot of people who are actually actively digging up stegosaurs. And around the rest of the world, the Jurassic seems to be just poorly exposed, or people just aren't really working on it. And I don't know why, because they're really interesting animals and they can tell us a lot about the evolution of the ornithischian dinosaurs, because they're some of the most primitive. So they're really informative about the rest of Ornithischia.
Mm-hmm. And what do you think the significance of this site is?
Well, we don't have a whole lot of specimens from the Morrison Formation that are actually found either articulated or associated. So lots of the Morrison material was just bone bed material. So you have a femur here, a humerus here, and we have no evidence that they came from a single individual. So this site's really interesting because you actually have two relatively associated specimens. We can pretty clearly say that, you know, which bones were from which specimen, certainly to a degree. The other really interesting thing about this is that at the moment we don't have any evidence that stegosaurs were gregarious. We have no evidence that they herded or they lived together in groups or family groups or anything like that. And so this is a really, really interesting site because we have what look to be three different stegosaurs, all within the same level, all within a small distance of each other. And certainly the two that we're excavating this year are very, very closely associated with each other. Now that could be, we could, depending on whether we find some more, we could sort of interpret that as evidence that they were living together and herding, or at least living in family groups. It's a bit problematic because they could also be coming down to waterholes, the last waterhole surviving in a time of drought. So it's a little bit difficult for us to definitely say that they were living in family groups, but it's certainly an interesting hypothesis, and I think the more we uncover here, and if we find more individuals, then that will become more robust.
So you said there's three here on the site?
Well, we had Gates over here, which was near Ralph, and then we had the two others, and it looks like you can look at the side of the hill and you can trace how the beds are dipping, and it looks like they're more or less on the same level. So
Gates was a different one?
Yeah, Gates was found the first year that they uncovered Ralph. They found parts of a stegosaur at a slightly higher level, just next door to Ralph. And he was quite fragmentary, so we don't have that much information. Yeah. But Gates looks to be quite an old individual, got very rugose bones, whereas the two that we have here seem to be teenagers, or they're large, but they weren't completely fully grown, so the bones aren't fused together. So in things like the ankle bones and the hip bones, in adult individuals, all these bones fuse together. But in the ones we have here, there's evidence that they weren't fused. So we seem to have different aged animals living together as well, potentially.
Do you have what percentage of the animals have you recovered out of here, do you think?
Well, for the one specimen, we've got quite a lot of the back half of the animal. So we seem to have, we've got the hips, we've got the pelvic region, we've got both legs, we've got a couple of feet, we've got several vertebrae from the tail, several vertebrae from the back, we've got lots of spines, we've got some plates. So we haven't at the moment found the front of the animal. We have got some skull. I'm not sure which animal that one goes with because it's kind of in between the two specimens, so we're not quite sure which one that goes with. With the other specimens, less well associated, so the material's jumbled up. But again, we've got the pelvic region, we've got a couple of femora, we've got quite a lot of vertebrae, we've certainly got quite a lot of tail vertebrae, we've got some neck vertebrae as well. So we've probably got about 40% of the one and maybe 30 to 40% of the other as well. So that's quite a lot of material.
That's pretty good.
We really don't have that many specimens that have that much material in from the Morrison, so it's pretty interesting.
And there's not many stegosaur around specimens?
No, certainly not semi-articulated or semi-associated specimens. As I was saying, there's, most of the material is bone bed material, so we just have odd bones, and we have the whole skeleton represented, but a lot of it is just odd bones from different individuals. There's maybe, I don't know, 7 or 8 specimens of Stegosaurus that are reasonably associated and reasonably complete. But these will certainly contribute a lot to our knowledge of and our understanding of the skeletons of these animals. In the Morrison Formation, we have evidence of two species of Stegosaurus at the moment. One called Stegosaurus armatus and one called Stegosaurus musi. And we haven't got any evidence at the moment that they lived together or at the same time, but they're both found in the Morrison Formation. So we don't know whether one was in the lower part of the Morrison, one was in the upper part of the Morrison, whether they lived at different times or whether they were two species that lived side by side in the same sort of environments and would have competed with each other. But the specimens that we have here, they seem to be referable to Stegosaurus armatus, which is similar to lots of the specimens that are known from Colorado and Wyoming from the Morrison Formation. And you can tell that because the dorsal vertebrae, the back vertebrae, look sort of stretched, so the neural arches are kind of elongated, whereas in the other specimen, in the other species, Stegosaurus musi, they're much squatter. And Stegosaurus armatus seems to have been a much bigger animal as well. So that works well with what we're seeing here. We've got some quite big femora, maybe over 1 metre long, and the hip bones are really quite big and robust. And as I said, I don't think they're fully grown. So yeah, it works well with that, them being Stegosaurus armatus.
So on these juveniles over here, how big were they being? How big do you think a full-grown one would be?
Well, it's difficult because reptiles have indeterminate growth, so they grow throughout their lives. And certainly their growth slowed down as they got to adulthood. But their bones and things like their plates, they carried on sort of adding bone to the bottoms of the plates over time. So you see some plates from very old individuals where the bases of the plates are really thick and rugose. So it's difficult to say what percentage of fully grownness they would have been, but I think probably the biggest femur I've seen from a stegosaur is about 120 centimetres long. So what's that in feet? Like 4 feet, something like that. Maybe just under that. And these ones are certainly not too far off that sort of measurement. So a metre, 10 centimetres, something like that. They're pretty big. So I would say these animals are teenagers, definitely approaching adulthood.
Would they be 10 meters long?
Maybe not quite that long, maybe 6.
And how high
7.
to the top of a spike?
Difficult to say, maybe 4 or 5 meters, something like that. The plates, you can have some plates that were up to about 1 meter tall. So you can have, they were made much larger by the height of their plates, which is kind of an interesting thought, given that if you were a predator, seeing these animals in the distance, you might think twice about going to approach them because they look much bigger than they actually were. The plates certainly were too thin to provide any sort of active armour role for the animal, but they could have deterred a predator from attacking them just because it made them look much bigger than they were.
Do we know if they were grazers or what their diet was?
Well, we don't have any grasses in the Jurassic, so they weren't grazing like the mammals that we see in this sort of environment today. But if you look at the way that they have very long back legs relative to their front legs, so their spine kind of angles down, and so we have to assume that their neck would also have angled down, because it would have been difficult looking at the way the vertebrae articulate with each other for the vertebrae to bend up and bend backwards on themselves, so they probably couldn't have lifted their head too high. So they were probably feeding on or browsing on the low vegetation. That would be things like ferns and mosses and lycopods, and things that were maybe 1 metre off the ground, that sort of thing.
So grass hadn't developed yet?
No, grass didn't evolve until the Cretaceous. So. And flowering plants hadn't evolved, so we were just looking at things like tree ferns, ginkgos, cycads, quite primitive plants.
And there's some controversy over how many species there were? Or is that...
Yeah, well...
or is that more resolved?
It's from around the world, many stegosaurs have been named, and this is what my PhD was actually about, was to go through all the specimens from all around the world that had been described and go and look at them and decide whether they actually were separate, distinct species, or whether actually it was just they were all referable to the same thing and people had just been a bit overzealous in naming them. And yeah, there was actually I think there was about something like 12 species named from the Morrison Formation by people like Marsh and Cope, who were really in the business of naming as many dinosaurs as possible. So as soon as they came across a new bone, they would call it a new species. So what I've just done is gone through all of them and compared all the material. And there may well be more than the 2 species that I've currently recognised in this formation, but I think that's all there's evidence for at the moment. So we may discover, we might even discover that these specimens actually provide information about the morphology and the bone shapes of these animals that would indicate another species is present. We'll have to, we won't know that until they're taken back to the lab and cleaned and prepared, and we can turn all the bones over and study them and compare them to all the others. But because of the poor state of preservation of lots of stegosaur material, and because we don't have whole, complete individuals known, it's very difficult, because you look at a single vertebra, you don't know where it came from along the back, so you compare it to another one and you say, well, this one's got a longer neural spine, or this one's got a bigger neural canal, but that could be related to its position down the back, as well as because they're different species, so it's very difficult at the moment. So I think that it's really important that we find specimens like the 2 we have here, because they are associated and we can tell where things came from in the body. So it's a pretty important discovery.
And how long have you been digging on the site here?
This is my 3rd year? I think this is my 3rd year. So I first came when we were uncovering Ralph's neck, and I spent I think 3 days digging in the site where they found Gates, the other stegosaur, and found absolutely nothing. And we didn't find much more of Gates at all. And then 2 years ago, we started digging over on the Rosie site and found an articulated back leg. And Nate had said to me to take everything out and just get it all jacketed and take it out. And it was the last day, and we kept digging and digging and digging, and we kept finding this femur going off into the hillside. And then I couldn't come back last year, but the guys came back and took out that leg last year, and then found everything else as well. So.
Yeah. Cool, thank you.
Okay.
I think we're done.